All right, this is Arithmetic Sequences and not being done in front of a live audience, but me and the tablet. So, -15, -7, 1, 9. Well, looks like we're going to be adding 8. So let's go with making this a pen. This. All right, I think we're ready now. So 17 and 25. It's been a while since I've written on a tablet, so. -4, looks like I'm subtracting 3 each time, so -16, -19. So we're pretty good at looking for patterns, but what do we get if we take -7 minus -15, which would be -7 plus 15, or 8, 1 minus -7, which is 1 plus 7, 9 minus 1, also 8. Or in this sequence, -7 minus -4 is -7 plus 4, or -3. -10 minus -7 is -10 plus 7. -13 minus -10 is -13 plus 10, also -3. Note that for each sequence, the difference between any two consecutive terms is the same value. So definition, a sequence is arithmetic if the difference between consecutive terms is it's the same value, so it's a constant. This constant is called the common difference. Lots of room to write that here. And is denoted by the letter D. So if you want to find D, you can take any term and subtract from it the preceding term. So T2 minus T1, or T3 minus T2, T4 minus T3, all the way up to T sub n, the last term, minus T sub n minus 1, which would be the term just before it. In order to find the 100th term of each sequence, it would be helpful to have a formula that relates each term to its term number. In other words, we don't just want to keep going until we hit the 100th term. We want to come up with a way to get there in one step. Complete the following table for the sequence. So we've got -15, -15 plus 8, -15 plus 2 times 8, -15 plus 3 times 8. And if we look at the relationship, this number here, the number in front of the 8, seems to be 1 less. And here you could think of it as we're adding no 8s, 0 8s, and that's 1 less than 1. So T10 would be -15 plus 9 times 8, right? Just 1 less than the term number. And here, -15 plus, well, we're going to go 1 less than the term number. That's going to be n minus 1 times 8. Complete the following table for an arithmetic sequence with first term T1 and common difference D. So in this case, we're doing a general instead of something specific with -15s and 8s. We've got T1, T1 plus D, T1 plus 2D. And you know, the T1 is just the first term, right? In this case here, it's the -15. And then we've got so many differences. So T sub 10 would be T1 plus 9D. And T sub n, the general term, will be T1 plus n minus 1 D's, right? N minus 1 times D. The general term T sub n of an arithmetic sequence is given by, so T sub n is equal to T1, so we always start with the first term, plus n minus 1 common differences, right? Plus n minus 1 times D. For the arithmetic sequence, -20, -13, -6, 1, etc., determine T35. Well, okay, if we want the 35th term, what we have to know is T1, which is -20, and D. So in this case, to go from -20 to -13, or this, I'm going to add 7 each time. If I want to calculate that, it's -13 minus negative 20, which is negative 13 plus 20, which is 7. So D is 7. So T35 is T1 plus 34D, or negative 20 plus 34 times 7. So I'm just going to go to my calculator here off screen. Go negative 20 plus 34 times 7 is 218. Okay, let's toss an equals in here, and that's equal to 218. Determine a simplified expression for T sub n. Okay, so we know that T sub n is T1 plus n minus 1 times D. T sub n, that's the thing we want to find. T1 is negative 20. The n is going to stay, so this will be n minus 1, and the D is 7. So if we've got an n here, we need an n out here. It'll be part of the formula. So negative 20 plus, we use distributive law, so we get 7n minus 7. Let's simplify, we get 7n minus 27. T sub n, T sub n. And I could check that with T35 by doing 7 times 35 minus 27. So I'm going to do that here. 7 times 35 minus 27 is 218. And we could also just think, well, look, this is T1, T2, T3, T4. So go 7 times 4 is 28, minus 27 is 1. Okay, so we have a good formula. Determine n if T sub n is 631. Now this is all part of the same problem, right? So we've got T sub n is 7n minus 27. So that's our formula. We're going to fill in 631 is 7n minus 27. Add 27 to both sides. That'll be 658 is 7n. So n is, what do we get? 94. So n is 94. So T sub n, the 94th term of this sequence, and by this sequence here, the 94th term is 631. Determine a simplified expression for the general term of the sequence displayed graphically to the right, and determine T30. So here, well, we've got T1 is 10, T2, right, because this is n and this is T sub n. T2 is 7, T3 is 4, T4 is 1, and T5 is negative 2. So looking at this sequence, T1 is 10, D is equal to negative 3, right? I mean, how do we go from 10 to 7 or 7 to 4? We go down by 3. Now, again, you could do this by going 7 minus 10 is negative 3. 4 minus 7 is negative 3. And determine T30. Okay, so we know T sub n is T1 plus n minus 1 times D. So in this case, we want T30, which is T1, 10, plus 30 minus 1 times negative 3. 10 plus 29 times negative 3. 10 minus 87, and we get negative 77 for T sub 30. Okay, that's all there is for example 2. If 4 minus 2x, 3 minus x, and 8 plus 3x are the first three terms of an arithmetic sequence, then determine the value of x and the value of the first three terms. Okay, so we've got T1, T2, and T3. Now, I know that d is equal to t2 minus t1, right? The common difference. You take any term, so 3 minus x, and from that, you subtract the first term, 4 minus 2x. So let's work this out. We'll just remove the brackets. 3 minus x minus 4, distributive law, minus 4 plus 2x. So negative x plus 2x is x, and 3 minus 4, x minus 1. So we know that d is equal to x minus 1. All right, well, how does that help? Well, what if we do d by going t3 minus t2? So d is 8 plus 3x minus 3 minus x, which is 8 plus 3x minus 3 plus x, which is, okay, so we've got 3x plus x. I'm just putting my x's first here, so that gives us 4x plus 5. So I have two different expressions. For d, it's x minus 1, but at the same time, it must be 4x plus 5, which means that I can set 4x plus 5 equal to x minus 1. Subtract x from both sides and move the 5 over here. So 3x is negative 6 and x is negative 2. So that's the value of x, negative 2, and then the value of the first three terms. So we've got 4 minus 2 times negative 2. Let's just work these out. So 4 minus 2 times negative 2, that's your first term. So that's 4 plus 4, or 8. Second term is 3 minus x, so 3 minus negative 2. 3 minus negative 2 is 5. And the third term is 8 plus 3x. So 8 plus 3 times negative 2 is negative 6. 8 minus 6 is 2. So with the sequence going 8, 5, 2. Common difference, negative 3, negative 3. Okay. Determine the number of terms in the arithmetic sequence. So I kind of like to list. What am I dealing with here? Well, we know T1, the first term, is 182. We know that the difference, so 178, how do you go here? You go down 4, right? So the difference is minus 4. We know that the nth term, we don't know what n is, but we know that t sub n, the nth term, is negative 14. And n, well, that's a question mark, right? That's what we have to find. All right, we have a formula. So again, anytime we solve something and we're going to use a formula, let's write it down. So t sub n is t1 plus n minus 1 times d. And let's just take the formula the way it sits, and now we can substitute in. And having listed everything here, we know what goes for t sub n is negative 14, t1, 182, plus n, we don't know, so let's go n minus 1, and d, we know, is negative 4. Okay, so if I'm going to solve this, I'm going to first subtract 182 from both sides. Negative 196 is negative 4 times n minus 1. Now let's divide through by negative 4. So 4 we're going to 250 times. So this will be 49. All right, where were we? So 49 is equal to n minus 1. The nice thing about solving, if you're solving for n, you know you're solving for a natural number. So n is 50. There will be 50 terms in this arithmetic sequence, right? You could count that out on your fingers if you wanted, but that wouldn't be a smart thing to do. Determine the number of multiples of 6 between 20 and 400. From 20 to 400. So the first multiple of 6 is going to be 24. A multiple of 6 means basically really just adding 6 each time. And the question is, where are we going to end? So let me just go here. 400 divided by 6 is 66.6. So I need 66 times 6 is 396. So this sequence ends at 396. And the question is, so how many of them are there? Again, let's list. T1 is 24. The common difference is 6. I don't know n. That's what we got to find. And T sub n, the last term in the sequence, is 396. Formula, T sub n is T1 plus n minus 1 times d. T sub n, 396, is 24 plus n minus 1, oops, I ran off the tablet there, times 6. First step, so let's subtract 24 from this. That'll give us 372 is equal to n minus 1 times 6. Divide by 6, so 36. 6 goes into 37. It's 36 times 36, 12, 62. 6 times 2 is 12. Carry the 1, yep. It's equal to n minus 1, and so n is 63. So there are 63 multiples of 6 between 20 and 400. The terms between two non-consecutive terms of an arithmetic sequence are called arithmetic means. Determine the 4 arithmetic means between negative 25 and 70. So that means that we have 4 terms in between negative 25 and 70. So we want to make an arithmetic sequence that has ends of negative 25 and 70 and has 4 terms in between. Determine the 4 arithmetic means. So let's take a look at this. This will be T1, T2, T3, T4, T5. This will be T6. So I know T6 and I know T1. And I know that, okay, so let's write this. So T1 is negative 25. N is 6. I'm going to need 6 terms, right? I've got the 2, and then I want to put 4 in between them, so n is 6. And T6, again, I wonder if I could pick that up, but I can, okay. So T6 is 70, and the question is, what's D? And once I know D, so if D is like 5, then I'll just add 5, add 5, add 5, and so on. So, formula again. There's no secret other than the secret that it's all about the formula. Substitution. Okay, and now we work this out. So I'm going to do what? Add 25. 6 minus 1 is 5, so that's 5d. So d, 95 divided by 5, is 19. So I want to add 19. It'll give me negative 6. I'm going to add 19. It's going to give me 13. I'm going to add 19, which is like adding 20 and subtracting 1. So that's 32. And then like add 20 and subtract 1. And then like add 20. Yeah. And there we go. So we have the 4 arithmetic means between negative 25 and 70. Okay, again, this is T1. And there's 4 terms, and then 70, so there's 6 terms in total. We've got T1. We know there's 6 terms. We know the 6th term, and it's the difference that we want. Once we have that, we just go along and add 19, add 19, add 19, add 19. And you could do that ad infinitum. If the first term and the 7th term of an arithmetic sequence are respectively 12 and negative 30, then determine the 26th term. Okay, so if the first term, T1, our 12 is 12, and the 7th term, T7, is negative 30, then determine the 26th term of the sequence. So when we've got n, so I need a general formula, right? Well, in this case, here's the formula we're going to use. T sub n is t1 plus n minus 1 d. All right, wait, so I know t1 is 12, so I've got t7. So for t7, what do we know? T7. So that's t7 is equal to t1, that's 12, plus n minus 1, 7 minus 1, times d. And you see the only thing we don't know is d. So let's subtract 12, and this is 6d, and so d is negative 7. So now I've got t1. I want the nth term, so I've got n, and I've got d. So let's set this up and work it out. T sub n is t1. Yeah, you're welcome. Plus n minus 1 times d. And what do we want? T26 is 12 plus 26 minus 1 times negative 7. 12 plus 25 times negative 7. And go to the calculator. 12 plus 25 times negative 7 is negative 163. Negative 163. That's T26, and that is what we were supposed to find. Is there more? Oh my god, it never ends. In an arithmetic sequence, we've got T12 and T13. Determine the simplified form of the general sequence, or the general term. Well, if we've got consecutive terms, then we know that D is equal to T13 minus T12, which is 25 minus 30, or negative 5. So I've got D is negative 5. And I want a simplified form for the general term. So we're going to need to figure out T1. Well, really that's about it, right? We need T1. So remember, general term. So we've got this formula for general term. T1 plus n minus 1 times D. So we could do this for T12, right? So we can go 30 is equal to T1 plus, now 30 is T12. So n is 12. 12 minus 1. And we've got D now. So 30 is equal to T1, and this will be 11, so minus 55. Add 55 to both sides. T1 is 85. Okay, let's go back over here. T sub n is T1 plus n minus 1 times D. And this time we want T sub n. 85 plus n minus 1 times negative 5. Now we just want to get a formula here, so we're just going to expand this out. So I have 85, and we've got minus 5n plus 5. So T sub n is negative 5n plus 90. Now if I want to check that, let's plug in T13, right? So we put a 13. Negative 5 times 13 is negative 65, plus 90 will be positive 25. T12, negative 5 times 12 is negative 60, plus 90 is 30, and so this is the answer we're looking for. It's a simplified form of the general term, right? Simplified form just means you can just plug in the n, and we just plug it in once, and we get what we're looking for. In an arithmetic sequence, T13 is 54, and T18 is 14. Determine the first two terms. Well, let's remember our formula. We need a starting place. So T18, let's just imagine it's T18. So 14 is equal to T1, we don't know T1, plus Okay, we know that it's 18, so this will be 17d. Now at the same time, with t13, we know that 54 is equal to t1 plus n minus 1, so it'll be 12d. And you can see what we've got here is a system of equations. And if I subtract 14 minus 54 is negative 40. T1 minus T1 is 0, but 17 minus 12 is 5d. So d is negative 8. Now, it wants the first two terms. So what we're doing, we'll just go into one of these guys, right? And we'll get T1. So let's put it into here. So now we'll say, all right, so 54 is equal to T1 plus 12 times negative 8. 54 is T1 minus, what do we got, 80 and minus 16. Add 16 to both sides, that'll be 60, so that'll be 150 is T1. So the first two terms, T1 is 150 and T2 is 150 plus 1 times negative 8, or just 150 minus 8 is 142. Okay, and if we kept going when we hit 13, we would have 54. Right, just imagine there's 150 there, it'd be 150 minus 96, which would be the 54, and T1 is 150 plus 17 times negative 8. 17 times 8. 17 times 8 is 136. So we'd have 150 minus 136, right? Because the d is negative, and that would be your 14. Okay, so there is a way to check. What? That's it? Okay, apparently that's it. We're done. All right, so this one was just me and the tablet again, because I wasn't there that day, but I will put this up shortly, and then we'll have everything available. So, TTFN.